Recording is starting. Cool. Okay. Let me load up a couple questions, and I'm just gonna straight up use I'm gonna use the ones that's in the videos. Is that fine for you guys?
Yeah,
So
that's fine.
the main three I'm gonna use is I know I'm not screen sharing yet. I need to open up another notebook. Let me. There's like 4,000 notifications going on. 1 second. 1 second. So there's main ones we're gonna worry about. Um, are you guys pretty familiar with the Laplace transformation of t by chance?
T, I think so.
Yeah, that's the trick. Not trick substitution. That's the integration by parts substitution. But I can
Oh
redo it.
yeah,
Yeah, I can
yeah,
redo it real
yeah.
quickly if you want. Okay, 1 second.
你在前面哦，我以为他停面哦，我以为我忘记啊，你
There's gonna be
谁估了？
screaming as well in the background. Don't mind me.
我讲喏，
T.
我是哎爸七个，
1 second.
我是七呀，
你手机记你按几多
我是七的，我讲我七的。
？1 second. Okay. The app randomly decided to update, so I have to like reinstall the update and then go on from there. It's funny too because you'll probably be able to see this in the recording. Okay, ready? So there's gonna be one main one. Okay. We'll focus on this, okay? So let's do this in order. So the Laplace transformation of any function is really just saying that the integral from 0 to infinity of e to the negative s t times whatever that function is. Okay? Does that part make sense?
Yes.
Okay. And honestly, if you guys have this equation, you're pretty much just good to go. Because what follows after this is just integration. Okay? Just any sort of integration. And if you want, we can do some integration practices. That's always pretty nice to have. And I can do some simple ones, I can do some hard ones, okay? But you can also rewrite this as limit as n goes into infinity of 0 to n of the e to the negative s t times f of t, which is a function. Okay? Do you guys understand how I got to this point? Because this is like the foundation.
Yes.
Okay. So we'll start with f of x is equal to, we'll start with 1, because 1's pretty simple. Then we'll do f of x, or f of t is equal to t. Then we'll do f of t is equal to sine. Okay? Is that
Yeah.
fine for you guys?
Sounds good.
Yep, and then whatever after that, I actually recommend using a table. But I'm also going to give you a couple examples on how to do a linear version of it, which just means if there's like a 3 in front of it, if there's a, let's say like a 10 in front of it, then you can do it pretty easily, okay? So we'll start with a 1 first. Plus A, B, C. Start with a 1, so A. For the Laplace transformation of 1 is equal to the integral from 0 to infinity of e to the negative s t times the f of t, which in this case is 1, times 1, which really just gets turned into the limit as n goes into infinity of integral from 0 to n. What's 1 times anything, guys? 1 times
Itself.
e, yep, is itself. There we go. So this just becomes e to the negative s. Okay? Now, this is just a simple u substitution. All that really means is we're going to take this part. We're going to plug it into this giant we're going to substitute it with u. Okay, so we're going to make sure that u is equal to this s function. Let's take the derivative of this, which du, oh, I forgot the dt over here. Du is equal to negative s dt, right? You divide this part over, negative s, divide by negative s. That means dt is equal to du over, I forgot the negative s. Okay? All that really means, there. Oh. But once we get this, you see how there's a dt over here, by chance? We're just replacing this dt by moving it over here, and replacing it by du. Because when you are changing a function from the range of u to t, we must change the derivative of it, or else it just wouldn't work. It wouldn't really make sense for you to do that. Does that make sense?
Yes.
Because, yep. So when you replace dt over here, you can rewrite this as a limit as n goes into infinity, have the integral of 0 to n of e to the u, because we replace this entire part to u. And we're replacing this dt now with du over negative s. Okay? And since this is technically a constant, we can move this constant right outside. So let's rewrite this as 1 over s times the limit of n goes into infinity of the integral from 0 to n of e to the u du. Okay? Do you guys understand how I got to this part? Do you guys understand?
Yes.
Yes. Okay. What about you, Gerardo? Are you keeping up? And if you're not, like I
Not
said,
yet. I'm still setting up my computer.
alright, no worries. So yeah, like I said, this is all recorded, so don't worry, okay? I'm gonna move this down over here, just so it's a little less messy, okay? So this is 1 over negative s of the limit as n goes into infinity. I have the integral of 0 to n of e to the u du. Okay. What's the integral of e to the u?
Would that be e to the u?
Yes. For example, what will be the integral of e to the x?
E to the x. Over? Wait. Oh, yeah.
So if it helps anything, if you're taking the grand integral of x, of e to the x, okay? It's always and always gonna be itself.
Ah,
Yes.
e to the x.
Because second thing about it, if you take the derivative of e to the x, you're moving this part down here, which this just becomes e to the x again, right? So if you do the opposite of this thing, it's always going to become itself again, isn't it? Because you're just moving this constant right back up to here.
I guess the only thing that changes is when you have something before the x.
Yes. So the only thing that'll
Because-
change, do you see how there was a s in front of the s in this time?
Yeah,
We're
yeah.
pretty much doing whatever we can to change this back into this particular form. That way, it's just simpler, it's easier, we don't have to worry about whatever constants in front of the x. Does that make sense?
Yeah.
Yes. That's all that u substitution is. We're simplifying the function by substituting a variable in front of it. That's all it really is. Okay? So now that you know
Yeah.
this, what will be the integral of e to the u in respect to du?
E to the u.
E to the u, perfect. So let's rewrite this. 1 over negative s of the limit of n to the infinity of e to the u, and we're integrating from n all the way to 0. Okay?
Yeah.
So now that we got to this part, remember that u is still equal to this negative st. Okay? You
Yeah.
Yep. So before we do anything else, we have to make sure we substitute you back into this area. Okay? So once we substitute everything back, this will become 拜托我做作业啊，你们闭嘴啊。Sorry, my parents are play fighting. Of s of the limit of n goes into infinity of e to the negative st from n to 0. Okay? And all this really came from is we're just substituting n back into here. Okay? Do you guys
Yes.
Do you guys understand how I got to this part?
Yes.
Yes. Okay. So now let's take the integration, or not. Well, let's find the n values and such. So remember that it's f of b minus f of a. Hello. I don't know who joined.
Hello. I joined.
Welcome back. Okay.
Mhm.
I explained this a lot better in the video, but don't worry. So remember that it's f of b minus f of a. If this is b and this is a, we're gonna rewrite this as 1 over negative s of the limit as n goes into infinity of e to the s of b is going to be n in this case, minus n. We're going to minus e to the s of a, which is 0 in this case. Okay? And let's simplify before we do anything. Okay? So, what's anything to the 0th power, guys?
1.
1? There we go. So we can rewrite this as just 1. Okay? And we're going to minus this by e to the negative s of n. Okay? What's another way of writing this e value? How can we rewrite this e value?
1 over e to the sn.
There we go, Sn. Okay? And this is being minus by 1. Now, I'm going to ignore this part. We're going to bring it back later. Because I don't want to rewrite it like 2,000 times. But if you add this limit as n to the infinite, as n gets closer and closer to infinity, we're pretty much just saying what would happen as this gets larger and larger and larger and larger. Okay? So as e to the sn gets larger and larger and larger and larger, what really happens to this function?
Turns into 0.
It's 0,
yeah.
so we can just cancel this entire thing out. Okay? So that means what's left is this negative 1, but we must not forget about this thing. So we move this thing back into the equation of 1 over negative s. We're going to re-multiply everything over. The negatives gets canceled out. And what's left over is 1 over s. And you're done. Okay. Do you guys have any questions so far? It looks like a lot of steps, right? It looks very complicated. But if you really think of this as a U substitution, as an entirety of a U substitution equation, it's not as bad as you think it is. Okay?
Yeah, I think I just need to rewatch the video and try it myself.
Yeah. So, in a little bit, I'm going to give you a constant version of this. And that just means that there's a 3 in front of the, it's a 3, it's a 4, it's a 5 instead of 1. And you guys can retry that, okay? Actually, speaking of this, do you guys want to try an example of this before we continue, just so you can get the idea drilled into your head? Or do you want me to just go to the next step?
I guess next step, so then we can just like finish the whole thing.
Yeah, that's true. Okay. So let's do B then. So B, I think was sine, right? Where was that T? So B was T. Okay. So if f of T is equal to T, the Laplace transformation of T is really the same thing as, I'm gonna move this down just so it's a little easier to see. Just when I'm just like floating mess over here. Perfect. Okay. It's really equal to same thing. It's the integral from 0 to infinity of e to the negative s t times the t dt, which we can rewrite this as the limits as n goes into infinity of the integral of 0 to n of e to the negative s t times t dt. Okay? Is that part getting drilled into your head yet? Do you guys know how we got to that part?
Yes.
Yes. What about you,
Definitely.
Gerardo?
I'm just cleaning up my room right now so I can turn on my camera. So I
I
wasn't
know.
looking at it too hard.
Pretty much, remember this particular step. And like I said, the video, you can rewatch it as much times as you want. Remember this particular
Yeah.
step, and you should be good to go, okay?
Okay.
Yeah. But let's continue from here. Honestly, a good way of doing this is let's just kind of ignore all the complicated stuff, okay? I know back then we kind of left this in, but let's just ignore it for a second. We're gonna just leave this by the corner over here, just okay? And let's just worry about this integral right in the middle, okay? So let's find the integral from e to the negative s t times t real quickly, okay? Let's not worry about all the limits, all the 0 to n, anything like that, okay? So what do you guys immediately see from this thing? What do you guys immediately see?
A harder integral.
Yes, a much harder integral. In fact, the number one way of finding an integration by parts is by looking for the functions. So for example, this is a function, this is the function. And you can tell they're not really in the same range, is it? Like you can
Right.
if t to the square, you can tell it's somewhat, it's in the same range as t, right? Same thing with like e to the, let's say 3t is in the same range of e to the negative st, right? But you can't, these two are just kind of in two different ranges, isn't it?
Yeah.
Yeah. So if those are in the two different ranges, that means these two are fundamentally different functions. Okay? And if they're fundamentally different functions, then you can almost immediately call out that it's an integration by parts. Okay? Now for integration by parts, I'm gonna erase this. For integration by parts, you can say there's two main things. You have to define what a u is. You have to define what a dv is. You have to define what a du is. I'm gonna, I don't know, quickly so you know which one's which. And we're gonna define what a v is. Okay? And the integration by parts usually take in the form of it was u, I think it was dv, right? No, it's uv minus the integral from v d u. Okay? I'm actually gonna double check before I continue because I know this can right. Who knows? One second, let me recheck just before I do anything.
That looks right. I have my quiz and I just did that, and that
Oh, okay,
looks right.
gotcha. Perfect.
U, dv, du, and v. Yes.
Okay, perfect. Bingo. Now let's define what u and dv is equal to, okay? So
Right.
if you look at the function, what will be the easiest to take a derivative of? Would e to the negative st be easier to take? Or would t be easier to take for the derivative? What's the easiest thing to take the derivative of in this case?
T. Well, right.
Yes. And why would it be t?
It's just simpler.
Exactly.
It's just
Because for t, in order to find the derivative of this, you have to take the what's it called? You have to chain rule it. You
exponent.
have to take the derivative of the very top, move it to the bottom. For t, the derivative of t is
It's just
just
one.
what? The derivative of t is just what?
One.
1, exactly. The derivative of t is just equal to 1. So let's plug t as u, and by process of elimination, dv has to be what's it called? E to the negative st. Okay. Now we know the derivative of et is equal to 1. Let's find the derivative of this thing we're fulfilling, okay? And if you were to take the integral from e to the negative st, okay, you can find that this is actually just related to this problem up here, okay? So do you guys want me to re-go over it, or do you think you can find it? Because the solution is it's literally right here. Do you guys want me to redo that u substitution just for practice? Or do you want me to continue and you can look back in the video for it?
For me, I would say for practice, to be honest.
Okay, gotcha. So I'll do it for practice then. So dt, remember u substitution. What will we have, what will we substitute u for in this case? What will make this integral 10 times easier to solve?
If the negative st was u.
If negative st was u, correct? So u is equal to negative st. It's a weird looking s. Okay. What's the derivative in this case? Okay, wait, before I do that. So now we've gotten rid of this darn thing, okay? But if it's just e to the u of dt, this doesn't really mean anything, does it? Because we're not really differentiating anything with dt. We're integrating something with u, not with et, right?
Yep.
So let's find what dt is equal to in terms of u, okay? So du is equal to you get rid of the t, and t is just 1, which is negative s, okay, dt. But if you divide negative s dt over here, that's an 8. I don't know why I thought that was an s. But on both sides, okay, you will find out that dt is equal to du over negative ds, okay? So let's resubstitute this back into here. And let's resubstitute this back into here, okay? So this will just become the integral as e to the u du, okay? Over negative s. Does me getting to this part, does this part make sense?
Yeah.
Yep. So like any other, since s is a constant, like any other constant, we can just move it out to the front. Okay. So let's rewrite this as 1 over negative s times integral of eu to du. Okay. And what's the integral of e to the u? du.
eu.
eu. Perfect. So this just becomes 1 over negative s of eu. Okay. And you notice that there's just this weird looking u still back, right? We pretty much got the thing done. But we still have this weird looking u, right? So let's resubstitute the u that we got originally from here. And let's just place it back. Well, why don't we just place it back? So what we're left with is 1 over negative s times e to the negative s t. And that's the integral. Okay? And this part was from the last one problem, so if you don't really understand this part, I actually recommend just, going back to this part because I explained it in a lot more detail there. Okay. But does that make sense on how I got to that part, by chance? Do you guys have any questions immediately?
Not right now.
No. What about you, Andy? Uh-oh.
No, I don't have any questions.
No, okay, gotcha. Yep. This part was kind of just review. Okay.
Yeah.
So let's replug this back into the equation. We know that V, that's a weird looking V. We know that V is equal to negative 1 over S. I'm actually going to leave the E at the very bottom. So E to the S T. Okay? Now let's plug this back into this equation, okay? We know what U is equal to, we know what V is equal to, we know what D or V is equal to, we know what DU is equal to, okay? So let's just plug this back into the equation. So we can say that the integral from E to the negative S, that's an 8. What's with me drawing 8s today, man? Times T is equal to U, which is T, times V, which is E to the, I'm actually gonna put this in the bottom. So it will be T over E to negative S T, okay? Multiply, or not multiply, divided by, or minus, English, minus the integral of 1 over S, or negative S, times E, where am I? Times E, there's an S in the very bottom, T. Okay, this is just me simplifying this. Okay, that's what I got from here. I plug this back into here. Okay, and then we're timesing this by du, which is just 1. Okay, and this is by dt. And now anything by times by 1 is itself. And since 1 over S is a constant, we're actually just gonna move this part out. Okay. So let's move this out. That means T. That's too low there. Over E to the negative S T plus, because negative times negative is a positive, plus 1 over S of the integral of E to the, I'm actually going to re-put the negative in front of S again, just so we can simplify a little bit, dt. Okay. Does everyone understand how I got to this part by chance?
More or less.
More or less, okay. I'm going this very slowly, by the
Yeah.
way. That's for a reason.
Yeah.
Okay. What about you, Andy? Does everything make sense so far?
Yeah, it's good.
Okay, gotcha. So let's take the integral of this, which we know is just this, isn't it? We've already done this integral, right? So let's just move whatever this thing is back into here, okay? So we're gonna do T over E to the negative S, T plus 1 over S. And we know what this, and that looks like an 8. I don't know why I'm drawing so much 8s today, man. There we go. And then we're multiplying this by whatever integral we just got from this, okay? Which we already technically solved for, which is over here. Okay? So this is negative 1 over S times E to the negative ST. Okay? Now it's just distributing. 1 over S times 1 over S. What is that? Hello?
Is it 1 over S squared?
Yes, 1 over S squared. That's correct. So let's rewrite this. E to the negative, E to the, I keep thinking that's an exponent. It's not exponent. ST. This will actually be a negative here. This will be a positive.
Because it's below.
Yeah,
Yeah.
because it's below you, right? There we go. Plus 1 over, or will be plus or minus? Will it be plus or minus? Hopefully you don't hear that loud buzzing in the background.
It's a minus, and we
Minus?
don't.
Okay.
At least I don't hear that.
Gotcha, okay, that's good. So minus 1 over s squared times e to the s, that's a 8, s t. Okay? Does that make sense so far?
Yep.
One second. I keep making a darn 8 for some reason. There we go. Okay. Now that we found the integral of this, let's replug in everything back in, okay? So the original limit of integration was from 0 to n. So we're going to replug this in from 0 to n. And it was from the limit as n goes into infinity. Okay? All we really did was we moved whatever the integral from here back into here. Does anyone have any question about how I got to this part?
No.
No? Okay, gotcha. So let's take the limit of, what's it called? Let's take the, I forgot what the term is, but you guys know what I mean. Where f of x, f of b, minus f of a, okay?
Yes. Do that form.
So let's replace everything with an n. We replace the t's with an n. So n over e to the s n minus 1 over s squared e to the s n, okay? And that's going to be minusing I feel like I forgot something. One second. Oh, yeah, there's an s here. I forgot s here, that's my bad. There's an s here and that's a negative. There we go. Sorry about that. Do you guys know where I got the negative from? The negative s in front from? Do you guys know where I got this from?
Yeah, it's right there.
Yeah.
Right?
Yep, it's from this. I just
Yeah.
forgot to I forgot the s pretty much. The negative of s.
Oh.
Yep. So I just replug this back in pretty much. Okay. But okay. Do you guys understand how I got to this point so far?
Yep.
Okay, gotcha. So if everything's a negative over here, okay, technically the entire function is negative. Okay?
Yeah.
So if we factor out the negative over here, and a negative times a negative is a positive, wouldn't this entire function
Yeah.
be
So the whole
positive as
thing's
well?
positive.
Yep, there we go.
Yeah.
So let's add. I'm gonna put parentheses just so it's a little easier. Of t, which is 0, 0 over s of e to the st, plus 1 over s of e to the st. Oh no, there's no t. There's a 0 in front of it. 0. This is also a 0. So. Okay. And immediately we can start simplifying. And don't forget the limit there. As n goes into infinity, okay? We can start simplifying now. What will immediately cancel out?
Let me take a gander.
Go for it.
So n is
Infinity.
a variable for infinity right now, right?
Yes.
Or no?
Yes.
So then both the n and the 0 are gonna cancel out. The ones that are on the numerator on the top
One
half.
second. The t does not work out. I don't think there's supposed to be a t on the top. Let me read you something.
Okay.
Ah. Yeah, the t's not supposed to be there. Can someone verify the equation for the integration by parts by chance?
Let me see if I can search it up and then share my screen.
Yep, no. Because infinity over infinity is a different law, and if I remember correctly, I don't think we speed it up. Here, 1 second. Let me double check my notes, okay? Sorry about this, guys. What? We need to start playing like Jeopardy music now, right?
Do you want me to show the integration by parts on my screen?
Honestly, go for it. 'Cause I have to remember what we did. If I ever looked. Fine. 1 second. I'm looking back on our quizzes to see what I messed up on for, you know.
Okay. But how come you know the t isn't supposed to be there?
Because n over n is infinity over infinity. Because as n gets larger
Yeah.
and larger and larger, this also gets larger and larger. That's a
Yeah.
contradiction. Because that does not exist. So I knew I
Wouldn't
probably
that
messed
just
something.
equal 1
No, it would not.
eventually?
Because
No.
that it has not been true. I wish it was equal to 1. Does that count?
Yeah, I thought of.
Oh, okay. That's a dilemma. One second, guys. I think you would need to use the Laplace thing here. Because on the quiz, we were taking the limit integration from 0 to 1, not to infinity. So I think you actually have to do something here. And that might actually be the reason why he didn't really teach you this. Or the Professor Dyke didn't really teach us this particular function. And that's I actually remember the formula for that. But it was in Calc 2, and it was, you know. Okay, but I'll ignore this part for now, okay? I'll ignore this part for now. Let's continue from here so we know which one gets cancelled out, okay?
Okay.
Yeah. So, as this gets larger and larger and larger, what does this become? 0. Bingo. As this gets larger and larger, or there's no n in it. What's anything over 0, guys?
0.
0. I love that. The lagging.
Like Andy's lag. Yeah.
Okay.
Andy, you're choppy.
What does this really become as you simplify this?
Is that a...
1 over s.
There's no n or t, right?
There's no n. The t is replaced by the 0.
Oh, so then it's just s of... Yeah, it's just 1 over
Yep,
s
1 over
or
s.
s to the
Perfect.
-1.
Plus of n over s of e of... Okay. I'm actually gonna leave this one out because I'm gonna be fully honest. This is so long back ago. I don't think I know how to do this.
Oh, okay.
It's like Portal, you know. When Klaus is like glitching out, you can hear.
It's the thought that counts behind the message.
Yeah. But I'm actually gonna leave this out, sadly. Unless you guys want me to look back like really far into my notes, for me to try to find this.
If we don't need it, then it's fine. You know.
Because honestly, if this is covered by the table, Okay, so it actually tells you the answer for the table.
Okay.
But if we're taking the limit from like 0 to 1 or like 0 to 2, the n will become a 2, and this will not be. You wouldn't have to deal with that pretty much.
Yeah, it would be like a real number, you
Yeah,
know.
it'll be a real number pretty much. But this you have to do. I think you take the derivative of both sides, and that becomes a quotient rule, and then you take. It gets very complicated. You have to see whether it converges or diverges. And I don't think you guys want to do that. But on the table, let me look at the table quickly.
Okay.
Yeah. On the table, I think this becomes n with the factorial n of s of n plus 1, I think. And in this case, if t of n for n is equal to 1, this would become 1 over s of 1 plus 1. This equals 1 over s. Okay? Okay. But we're going to leave out of that. Do you guys understand everything over here so far?
Repeat it?
Do you guys understand everything in here so far?
Yeah.
Yeah.
I just do you see the symbol on Andy's
On
profile?
Andy. Where?
It
The
says
mute?
user may be having trouble connecting to the call.
That
So
I do.
thank God you recorded it.
It's everything is recorded, so it's fine.
What happened?
Yeah.
Up. All right. But yeah. We'll leave it as that because I don't want to look back into my notes yourself for the start thing. I really don't.
Yeah.
Yeah. But here, let me actually check. Okay, cool. Now let's move on to sine. If I remember correctly, I don't think you need a trig substitution for sine, do you? If we do, we're skipping sine because I don't want to do trig sub. No, we did not. We did not. We did not. Did we? Let
For
me look.
sign.
Yeah, let me look back in my notes. I don't think we needed to do a trig substitution for sine, right? 1 second. Oh God, I'm in my Calc 2 notebook, and that brought back like a wave of memories of trauma, man. um, of, of sine.
Corridor crew.
Hello. How many? How many? Two? Two. Have you guys been here before? Guys, welcome back. Let's see. Follow me, okay?
Andy, is your Wi-Fi working?
Sorry about that,
I
guys.
think I did get I did get like the stream kicked out or something.
But that's not good.
Yeah, but
Can
it's
you
back.
watch or no?
Yeah,
Oh,
I
okay.
can see.
Okay. Yeah, so sine does require trig substitution. So we're gonna ignore that one because I highly doubt he wants us to do a trig substitution on the exam. Okay, I highly doubt it.
Where's the sign? I don't see the sign.
The sine is all the way. So I have 3 problems laid out, and that was sine t and then 1. Okay.
Oh,
Yeah.
okay.
We're gonna replace the sine because that's a trig substitution. I do not want to deal with that, and absurd. And I highly doubt.
All right, so we did.
Yeah.
Yeah, we did A and B.
Yep, we did A and B. Well, B quote unquote. We did A and B.
Yeah.
But
Okay.
I'm actually gonna do E now, since E is a little easier. We're gonna do E of A T.
Okay.
And then anything else, whether that be cosine, sine, or anything, you'll be using the table. Okay. So let's move on
Okay.
down, which is very laggy for some reason. And let's use E. There we go. Where f of t is equal to E of A t. Okay? Same thing, Laplace transformation of E to the AT. Also, is Andy back?
Yeah.
Okay, nice. Welcome back. Is equal to the limit as n goes into infinity of integral from 0 to n e to the negative s t times e to the a t. Okay? dt. Right? So yeah, we're pretty much gonna ignore everything over here and let's just take care of this integral first, okay? So integral as e to the negative s t times a to the a t dt. Or e to the a t, I mean. Okay? How would you there's another way of rewriting this. How would you rewrite this? There's
Uh,
another way of rewriting this. How would you guys rewrite it?
Isn't it ST plus AT?
Yes, there we go. So, and then if there's an exponent, let's say like this, times x to the third, this will really be x to the 2 plus 3. We're using the same concept here of integral. That's a weird like integral. That's an s right there, man. There we go. E to the negative st of e to the at. This is really the same thing as saying e to the negative st plus at. Okay?
Okay. Could I ask,
Go for it.
how did you know to take the limit? Like that it becomes that,
Yeah.
like
So
the limit into infinity.
the original thing was it was the integral from 0 to infinity of e to the negative st times the f of t. And this is given, by the way. This is given.
Oh, okay.
Yep. Any Laplace transformation, it requires this, what's it called? Equation. And the limit is just really a
And then
way
you
to take
just
care of this. Yeah. And limit is just taking care of
yeah,
this.
and you
That's all
just
it is.
plugged in the FT.
Yep, you just plug in the f of t. And
Okay.
I would have this
Understand.
written down in your note card or anything like that, okay? Because this is the foundation of the formula. This is the foundation.
Okay.
Perfect. And I can review this again tomorrow if you ever need to, okay? But like I said, the video's it's recording. What's the hour long? It's already 50 minutes long. Okay. So, what does this look like? How can we make this integral 10 times easier to take care of?
If it was you,
If it was u, perfect. So what will u be equal to?
negative S of T plus A of T.
There we go. Plus a of t. Okay. And normally we'd just immediately take the derivative of this, but because I know from memory, for this problem and only this problem particularly, factor out the t, okay? But not just any t. Let's factor out a negative t, okay?
Okay.
Yes. So in this case, if we were factor out a negative t, it will be negative t times s plus or minus a, okay? And now let's take the derivative of this. So du is equal to, since all of this is really a constant, we can treat it as a constant. Okay. What's the derivative of negative t?
-1.
Negative 1. Negative 1. This is just another constant, so we can just kind of leave it as this. So it'll just be negative of s minus a. Okay? Does everything over here make sense? Does everything
Yep,
here
it
make
makes
sense?
sense.
Okay, gotcha. So yep, same thing as last time. We're just solving for dt here, divided by negative s minus a, divided by negative s minus a. Okay? So dt is equal to du over negative s minus a. Okay? Now let's substitute this back. We're replacing it back into the thing, just like what we did before. Okay? I highlighted over the wrong thing. Come on, there we go. Moving this back into here, okay? So that will be the integral of e to the u du. Du divided by negative s minus a. Okay? Now, immediately, what can we do about this weird looking thing? Technically, it's a constant, right? What would we do with it?
We could drag it out,
Drag
or
out?
I don't
Okay,
know
yeah.
how to say it.
Yep. I just say move out to the front, drag out also works. So let's move it to the front.
Yeah.
I'm gonna move down a little bit just so we have a little bit more room. But 1 over negative s minus a of the integral of e to the u. Okay? And now let's take the integral. What's e to the u? What's the integral of e to the u?
Integral of e to the u is e to the u.
E to the u. Perfect. So 1. Uh-oh. He's back to robot mode. Times e to the u. And what's u equal to? What's u equal to? So we've officially taken the integral of this, but we still have this darn u. Okay. So what is u equal to in this case?
U is equal to negative s t plus a t.
Perfect. So, well, actually, no. It will be the second version. You remember how we distribute a negative t out?
Yeah.
Sorry. Sorry. That's the most gladiator. uh, once once we're done with this lesson, Andy, you have to just go back to the recording, okay? The minute is probably around like what, like 50. Look for 50, and you just have to listen to the way you talk, okay? It's hilarious. But it's actually this version because we've already factored out the negative t. We kind of need this negative t out here, okay?
Okay.
Yeah.
Just for convenience, right?
Yep. It's so when we plug everything back in, everything does not just zero out pretty much.
Okay.
So let's replug this back into u. Okay. This will just become negative 1 over s minus a times e to the negative t of s minus a. Okay? And since this is a constant, actually no, yeah, before we deal with that, let's now reintroduce back this concept, okay? So we're just replugging everything in. We know that the integration of constant is from 0 to n, and we know that there is a limit as n gets closer and closer to infinity. Okay? One second, I just got text. Okay. Ready? So then let's take the let's substitute everything back in as, remember, it's f of b minus f of a. I write this down mainly for me than anything. So we know that b, if we substitute n and b, I'm gonna write the limit as n goes into infinity, just so we don't forget about it. If this is a, this will become negative 1 over s minus a. I don't know, times e. Okay, what's another way of rewriting this? We've done this version a million times. What's another way of rewriting this? This will be,
The E. Oh, like 1 over.
yep, 1 over there. You got it. 1 over e to t of s minus a. It's a weird looking line. Okay? And this will become an n because we're replacing the t with n. Okay? Let me erase it back because it's bugging me. Okay? And that's minusing, but since the original thing was already a minus, negative times negative is always a positive, so this just becomes a plus. Plus 1 over s minus a times 1 over e. Since t is equal to 0 in this case, this will just become 0. Okay?
Okay.
Yeah. And then,
So you said we're replacing all N or all T's with N or negative T's.
so you saw how everything out there, we had like a integration part. So it was from
Oh, yeah,
0
yeah.
to infinity. Yeah, we're just doing that pretty much. We're replacing every t's with n's and every t's with zeros.
Okay,
So,
okay.
yep, this part's A, this part's B. Does that make sense? And
Yes,
that's,
it does.
yeah, and representing these two. Okay? Does that make sense before I continue?
Mm-hmm.
Okay, gotcha. Perfect. So as this goes out, let's actually simplify this now. This is a very easy simplify. As n gets bigger and bigger and bigger and bigger, what does this become?
So that one becomes
N gets bigger and bigger and bigger and bigger and
0,
bigger. 0, perfect. What's 0 times anything?
0.
0, so this entire thing gets canceled out. Okay? Now, what's e to the 0, guys?
E to the 0 is
1,
1.
there we go. So, what's left over is really just 1 over s minus a. And you're done. Bingo. Does that make sense?
Yep.
Yep. If we actually look back on our table, so I'm actually gonna pull back our table stuff. Oh wait, this is my physics folder. Oh crap. Wait, why am I in my physics
Different.
folder? It's fine. It's fine. It's fine. Let me pull up a table from thing. So it's 1 over s minus a. So I can actually find my math folder quickly. Just all the way back then. 1 second, guys. I think it's over here. A little bit further back. There we go. You can see this is 1 over s. 1 is 1 over s. So bingo.
Yeah.
Cool. Do you guys have any initial questions then? Because that was the 3 Laplace transformation that you probably should have worried about.
Okay. No, I don't.
No?
But I probably
Okay.
also need to rewatch the video.
Gotcha. And I went over things really slowly as well. At least I hoped I went through it really slowly without me.
No,
You
it
know.
should be good. It should be good.
Okay. But yeah, bingo. You guys should be good for that. Okay.
Yeah.
Yeah. Is there anything else you guys want me to go over? Do you guys understand all the matrix stuff? Because the matrix stuff is pretty important as well.
I would like to revisit the matrix stuff a little bit, just to make
Matrix.
sure I have a good understanding of it.
Okay, gotcha. So the basic matrix idea is, you guys remember the equation of x prime is equal to a x by chance? Do you guys remember that equation? For
Yeah,
a, yep, a is the constant of all the stuff. So for example, if we had like where x prime is equal to x plus y, and y prime is equal to. I think this is literally a quiz question, by the way. Okay, where this is all the coefficients. So technically, there's a 1 in front of these, and a is really the coefficients of these things.
so it would be 1, and -1.
Oh yes, that's correct. You're correcting teacher. That's nice. Extra credit. Man, I wish I can give extra credits, man. Okay. So we're gonna replace this thing over here. That's the same thing as saying x prime of y prime, and I just got it from over here. Okay. Equals the constants of all the x and y's of 1, 1, 1, -1 times all the x and y's, so x and y. Okay? And that's all that's all already done. Okay? Now the second most important equation is this, which is it was a minus lambda I times the constant is equal to 0. You guys remember this one?
Yeah, I remember this one.
Yes.
So that would end up being just the lambdas down the diagonal because the identity matrix.
Yep. That. From what I could understand, yeah, that sounds about right. So yeah, this will be a minus the lambda minus the identity matrix. You're right. Which identity matrix is this? And this is all volume being multiplied by c is equal to 0. Do you guys remember how to find lambda by chance?
Mostly, yeah.
Okay.
It wasn't too hard.
Do you guys want me to go over, or do you want me to like just go over briefly like tomorrow or something like that?
I think we might as well do it in the video so that I can practice more
Yeah,
and
that's
then
true.
be prepared for tomorrow to help you guys.
Okay, gotcha. Okay. So yep, let's solve for lambda here. So this actually might not be solvable because this is not a practice question. I could just be making. This is completely made up. Okay. So if this does not work out, so be it. Okay.
It's fine.
Good. Let's solve for lambda. We know what a is equal to, which is 1, 1, 1, -1, minus the lambda, which is lambda 0, 0, lambda. Okay. And since we don't really have to worry about the c because we're just worrying about everything that's inside. We kind of just divide it here. Okay. So let's subtract everything across. 1 minus lambda. 1. This is 1 minus 0, which is 1. This is -1 minus lambda, which is 1. Okay. Now we're gonna take the determinant of this. Do you guys remember the determinant formula?
Yeah, it'd be a times d minus b times c.
Yep, perfect.
Good
I
job,
don't know if
Andy.
you can hear
I
that.
barely heard it until the end.
But yeah, a times d minus b times c. Okay. Now we're just plugging everything in. This is a, this is b, this is c, this is d. Okay. So a is 1 minus lambda. B is negative 1 minus lambda. Uh, D is negative 1 minus lambda, I mean. B is 1, and then C is also 1. This just becomes 1. Okay? So let's actually factor this thing out, or distribute this. So this will just become negative 1 minus lambda minus lambda. Hold on, I lost track. Where am I? Negative 1 minus lambda. This actually would be a plus lambda, and this will be lambda squared. And then minus 1. Okay? This will actually cancel out. And this will become... What was I gonna do? Where did that 1 come from? Where did this thing come from? 1 second. There we go. These two
I'm
canceled
catching up.
out. Yep.
Yeah.
This thing and this thing adds up to negative 2. So it'll just be negative, or lambda squared minus 2. Okay? Now, this actually might be an
Okay.
imaginary number, because, like I said, I made this up. So this might not work.
Yeah.
But we'll try it anyways. I would definitely use the quadratic formula, which is plus or minus b squared, or b. I messed that up already. B plus or minus the square root of b squared minus 4ac over 2a. Okay? And b is equal to 0 in this case. Actually, here. What is a equal to?
What?
For the quadratic equation?
A is equal to 1.
1, there we go. Is equal to 1. B is equal to
B is equal to 0.
0. What's
0.
C equal to?
Negative 2.
Negative 2. Perfect. So let's plug everything in. We don't really have to worry about b, nor do we have to worry about b squared. So that's
Because
just
we just
Wait, how'd you get a negative 2? I didn't get that.
negative 2. So when you factor out this thing, you'll get negative 1 minus lambda plus lambda, and then lambda squared. There's also this 1 times 1 at the very end. That became negative 1.
Oh, yeah, I forgot to carry that one.
Yeah. So,
Alright, now I understand.
yep. When you add these two negative 1s together, you get negative 2.
Yeah.
Perfect. So now let's plug everything in. It will be plus or minus the square root of negative 4 of a, which is 1 times negative 2, all over 2a, which is just 2. Okay? I'm kind of glad. I'm kind of glad that this is a real number and not a imaginary.
Yeah.
Yeah. But
Lucky roll.
I was about to. I was fully expecting this to become an imaginary number, and I would have cried myself to sleep. But you can. This would become. This would become the square root of 8 over 2. And you could simplify. Do you guys want me to teach how to simplify this, or do you think you're fine?
That'd be the square root of 4 times 2. And then you can take the square root of 4. And that becomes 2. And then divide by 2. And it becomes the square root of 2.
From what I can make out, I think you got it. But let me let me rewrite this because I don't think I could. I don't think I caught that
No,
one.
I understood what he said.
So you have
Understood.
8, you have 4 times 2. This is technically 2 times 2, which is the root. So you just move the 2 out to the front. Okay. Is that what you said? Because I did not.
Yeah, that's what I said.
Okay, that's okay.
I wonder if it would be the square root of 2 because it's lambda squared minus 2 is the difference of two squares, right?
Gotcha. Oh yeah, you're right. Yeah. Huh. That's pretty interesting. Okay. Cool. But yeah, this will be transformed into 2, the square root of 2 over 2. These two gets canceled out. So we have lambda. What's lambda? Lambda is equal to plus or minus the square root of 2. Okay? Do you guys get how I got lambda here?
Yeah, I just ran out of space in my notebook.
Well, granted, we just had to deal with that, the last page chaos. So, do you guys remember how to solve for for what did you want? What you go on from there? So pretty much now the idea is, we're going to replug this back into the equation, which is lambda I times the constant is equal to 0. We know that lambda 1 is equal to square root of 2. Lambda 2 is equal to negative square root of 2. And we'll just plug everything back in until we can find the constants. Okay. Do you guys remember the general solution of this by chance? Because that's very important.
You're right. I need to write down the form.
Yes. Do you guys anyone wants to take a shot at it before I write it down?
Let me see.
Andy, you think you got
the
it?
top of my memory, I don't have it. What the heck?
Just scream it out if you think you know.
Where's my general form?
Okay.
Times the eigenvalue. I guess we simplify it.
I think I got that. You're gonna have to tell me this.
Is it the C1?
Oh yeah, the C1. Yeah, you're right. You're right. There we go. You got it.
Yeah.
But yeah, strongly advise you to remember this one. Okay. Out of everything, please, this one. Okay.
I'm gonna take a picture.
Yeah. But like I said,
I'll
this isn't a
remember.
video. Okay, so you should be fine.
No, yeah, just to have the photo so it can remind me just that specific part. Just put it on my notes.
Okay. But then, do you guys want me to go on to how to solve the lambda and stuff? Because the square root does get a little bit annoying, but you can just do calculator work. Where you just plug everything in, and then you find the eigenvalues.
Yeah, that one should be pretty simple.
Pretty simple, okay.
Yeah. Question is good for you for that.
Yeah. Okay, gotcha. Perfect. Did you want review, Andy? I couldn't really understand it.
No, that's fine. I
Oh,
think
what the heck?
10 is...
Wait, he just went back to normal.
It's all part of a game.
Okay, so we should be fine. Perfect. Do you guys want me to go over any linear transformations in the separation by parts? Or do you think we should just practice? Yeah. Or do you think we should practice that tomorrow?
We could practice it tomorrow.
Tomorrow? Okay. What about you, Andy?
Yeah, we should that tomorrow.
Okay, gotcha.
No, he switched back.
Perfect.
No!
Oh crap. Yeah, tomorrow. Okay. I'm gonna end the recording then. I'm gonna post this on YouTube, and then I'll just paste on chat if ever needed. Okay.
竟然结束了。
Okay.
Perfect. So.